Proving double angle identities. This is the second example here. We have sine 3x is equal to sine of x times the quantity 3 minus 4 sine squared x. If we again look at our sum and difference identities, we can rewrite sine 3x as sine of x plus 2x. And then using those sum and difference identities, I'm going to rewrite using the formula here, sine x, so sine of the first angle, times cosine of the second angle, plus cosine of the first angle, times sine of the second angle. And now we're going to use our double angle identities and replace the cosine 2x and replace the sine 2x. If you look at the right-hand side of the equation up here, we're left in only terms of sine x. So we're going to use the cosine 2x. We're going to replace that with the one that only has sines in it, which is the 1 minus 2 sine squared x. So that is going to be multiplied by sine x. And then we have plus cosine x back here, and that's going to get multiplied by our replacement for sine 2x, which is 2 sine x cosine x. All right, so now we have to distribute into the parentheses. So we're going to distribute sine x into the parentheses. So we have sine x minus 2 sine cubed x plus, when I distribute cosine x in, I'm just multiplying the two cosine x's. So we're going to have plus 2 sine x cosine squared x. Now I again have another cosine squared, and in that cosine squared, we're going to replace that using your Pythagorean identities, which says that cosine squared x is the same thing as 1 minus sine squared x. So now we have sine x minus 2 sine cubed x plus 2 sine x. That's going to be multiplied by the quantity 1 minus sine squared x. So we're going to distribute this 2 sine x into the parentheses here. So we have sine x minus 2 sine cubed x, and when I distribute, I get plus 2 sine x, and then 2 sine x times negative sine squared x, I get minus 2 sine cubed x. All right, well here we've got like terms we're going to combine. We have a sine x and 2 sine x. That's going to give us 3 sine x. And then you have negative 2 sine cubed x and negative 2 sine cubed x. So we get negative 4 sine cubed x. Look back up at the right-hand side of that equation up there, and we need to factor out sine x. And when we factor out sine x, now we have 3 minus 4 sine squared x. And we've just proven the identity on the right-hand side of the equation.